Like I already promised you, the jambas amongst us already promised you that I was going to revise the whole of physics textbook with you before your examination. That is 2026 jam. Even if you are also preparing for work, this class is also very important for you. So please pay attention. Watch this. Make sure you are patient enough to watch this video till the end, because you are actually going to benefit. Okay, or pick in your physics textbook is fundamental quantities, physical quantities. So from the textbook, from your textbook, or from your SS1 class, they will tell you that physical quantities are divided into two parts. You have the fundamental quantities and you have the derived quantities. Physics, in fact, you cannot talk about physics generally without talking about physical. Physical quantities are the things that makes up physics. Yes, you cannot talk about physics generally without making reference to physical quantities. So physical quantities generally are now classified into two. You have derived quantities and fundamental quantities. Fundamental quantities are the quantities that are independent. In other words, they can exist on their own. They don't depend on other quantities for existence. Do you understand what I'm saying now? They don't depend on other quantities to exist. They can stand on their own. They are independent. Okay? While on the other hand, derived quantities are quantities that depend on the fundamental quantities for existence. They cannot stand on their own. Okay? In fact, from the word derived, in other words, all derived quantities are gotten from combination of two or more fundamental quantities. It could even be one fundamental quantity repeating itself here. So derived quantities are gotten from the combination of two or more fundamental quantities. Please, let's come back to derived quantities. Please make sure you are writing. Okay, you see my body is very small. I don't want to use my writing to cover up everything. So as I'm talking, make sure you are jotting down something, because we have a general group, right? I will be asking you questions based on the video, this video I am sharing with you right now. So make sure you are jotting down something. Okay, a lot you would learn. I will show you how JAM usually sets their questions from this topic, how they tend to confuse many students. And then you see questions coming from derived quantities and fundamental quantities, dimensions. Some students don't even know that this particular question is coming from dimension. Why? Because the basic knowledge, the basic understanding, they are lacking it. So I am here to set the foundation on dimensions for you. So when you see questions coming from dimension, you will not be confused. Okay, so please pay attention, get a writing material, jot down, I beg you in the name of God, so you will not miss out in any piece of information I will be sharing on this video. So please, in fundamental quantities, there are three major quantities you should always keep in mind. Fundamental quantities, there are more than three, but there is these three very important ones. We'll be talking about mass, length, and time. You cannot mention fundamental quantities without mentioning these three. I told you to go and prepare. So make sure you study other examples of fundamental. They are in your textbooks. Okay, you have your textbook with you. It's not everything I will be teaching you. So I will just be touching some important areas that I know you know. Not that the other ones are not important, but you can visit your textbook and understand them yourself. If you have any question, you can always ask me. You have my contact already for those that already saved my number. So mass, length, and time, they are the major fundamental quantities. It is from these quantities that derived quantities are gotten from. Combination of these three quantities. Okay, so these are the major examples of fundamental quantities. There are other ones, so current, luminous intensity, amount of substance, all of those things, temperature. There are other examples of fundamental quantities, but the three major ones, please take note of this. The three major ones are what? Mass, length, and time. Just the same we have physical quantities, that's how we also have physical units. If we talk about fundamental quantities, we also have fundamental units. Fundamental units are the units of the fundamental quantities. Please take note of it. Fundamental units, every physical quantities in physics has their own units. Okay, so fundamental units are the units of the fundamental quantities. What do I mean? We just mentioned some examples of fundamental quantities, which is mass, length, and what? And time. So the unit of mass is kg. The unit of length is meter. The unit of time is seconds. Meter, kilogram, meter, seconds. So all these are you call these fundamental units. Why? Because they are units of these fundamental quantities. Have this, don't forget this. I don't know how some students will, you are writing jam, you don't even know the unit of mass, length, and time. If there's anything you should not forget, or if there's anything you should know this and their units. I beg you in the name of God. Don't forget, the unit of mass is kilogram. The unit of length is meter. The unit of time is seconds. Take note of it. There are other units like minutes, hour. Those one have to do with, of course, you convert. I will also teach you how to convert, because this is one aspect of physics that many students are lacking. They don't know how to convert one unit to another. They don't know how to convert, and they don't even know when to convert. You may even know how to convert, but when to convert is another thing many students don't know. So as you follow me in this tutorial, I will be exposing those things to you and how you can effortlessly do them. Do you understand now? So these are the three major fundamental quantities and their units. The unit of mass, once again, is kilogram. The unit of length is meter. The unit of time is seconds. Please take note of it. Let's talk about derived quantities and derived units. Some of the examples. For instance, we already said that derived quantities are gotten from fundamental quantities, right? So let us mention some examples of derived quantities. An example, you have area. What is the formula for area? Area is length times breadth. Now, if you observe this, length and breadth, what makes up the formula for area? They are both coming from this length. That's why we said area is gotten from multiplying two lengths together. That's why we said derived. Area is derived from this. Formula for area, it was derived from this. If you multiply two lengths together, that gives you area. That's why they call it derived quantity. Another one is velocity. Velocity is displacement over time. Displacement over time. You see now, this displacement is still talking about length, length and time. You see, if you combine length and time, it gives you, find the ratio of length and time gives you velocity. That's why we said, that's why we call them derived. This one is gotten from length and time. You can see, length and time. Another one is let me say volume. Volume is length times breadth times height. Gotten from length, breadth, and height. Combination of everything is coming from this length. Multiply three lengths together, it gives you volume. Okay. Now listen. If you know the formula of any physical quantity or any derived quantity, the unit will also be very simple to get. Some persons, if I say what is the volume of the unit of area, you don't know, but you know the formula. From the formula, you can know the unit. Now, if the unit of length is meter, unit of breadth is also meter. Meter times meter gives you meter square. So it means the unit of area is meter square. The same thing here. The unit of velocity is displacement. The unit of displacement itself is meter, and the unit of time is seconds. Anytime I see anything divided means per. So if I want to call the unit of velocity, I will say meter per. Changing this division sign to per, like you call it per seconds. Some persons write it like this: meter like this minus 1. If you have done indices in mathematics, you know the reason why this one is the same as this in mathematics. We will still do indices in mathematics. So meter per seconds, that is the unit of velocity. What about volume? This is meter times height is also meter. Height, everything is talking about length. Length, meter. Breadth is still talking about length, meter. It's meter. So if you multiply everything, it gives you meter raised to 3, meter cube. That's why our volume, the unit of volume is meter cube. Meter cube. Sorry. Anyway, let's continue. Another one is Another example, if you know other example, please drop it at the comment section. Other examples of derived quantities, other examples of fundamental quantities, put them at the comment section. Other examples of derived quantities, also put them at the comment section.